Quick revision video on titration calculations, also known as volumetric analysis. So we'll start with the essentials. Volumetric analysis is a technique used to find the volume of one solution which is needed to react with a measured volume of another solution. The concentration of one of the solutions must be known exactly, and that's what we call a standard solution. In acid-base titrations, an indicator is used to show when the exact volume of solution being added from the burette has been added. In the calculations, the three steps that I use are step 1, moles of known substance. So that's basically the chemical you know the concentration and volume for. Step 2, we use the mole ratio in the balanced chemical equation to get the moles of the unknown chemical. And then step 3, we answer the question. Usually that's to calculate the concentration or the volume required of a particular solution. So you'll see me using those steps in the calculations that follow. And the final essential is the formula we use that links moles, concentration and volume together. So there it is there. One thing to note is that the volume of the solution is in decimeters cubed, and often they'll give you the volume in centimeters cubed. So I've got 3 examples for you to try, so if you want to pause the video now, have a go at them and then play on when you're ready for the answers. So example number 1, we've got to calculate the concentration of the sodium hydroxide solution in moles per decimeter cubed and grams per decimeter cubed. So the first thing we're going to do is calculate the moles of the known chemical, so that's the hydrochloric acid in this case. We've got the concentration and volume for that, so we get 7.05 times 10 to the minus 3. Nice easy mole ratio of 1 to 1, so the moles of NaOH in that 25 cm cubed used in the titration is going to be the same. And then we just apply the formula, so concentration is moles divided by volume. So concentration comes out at 0.282 moles per decimeter cubed. And finally, to get the concentration in grams per decimeter cubed, we're going to bring in another formula. So it's the formula for solids now. So mass is equal to moles times molar mass. Well, we've just calculated the moles per decimeter cubed. So to get the grams per decimeter cubed, it's just moles times molar mass, or MR, of the NaOH. So it's 0.282 times 40, 11.28 grams per decimeter cubed. Example number 2 is very similar, it's just a slightly different mole ratio going on. So the known chemical this time is the sodium hydroxide. We've got the concentration and volume for that. So moles of NaOH is 5 times 10 to the minus 4. The moles of the sulfuric acid will be half of that because of the mole ratio. So that's 2.5 times 10 to the minus 4. And those moles are in that 28.2 cm cubed of sulfuric acid. So the concentration, therefore, is those moles divided by the volume that they're in. And it comes out at 8.87 times 10 to the minus 3 moles per decimeter cubed. And then as grams per decimeter cubed, we just multiply those moles by the MR, which is 98.1, and we get 0.870 grams per decimeter cubed to 3 significant figures. The final one, we've got to calculate a volume required now, so we're sort of flipping the formula triangle slightly. Same method though. So moles of known chemical, we've got the concentration and volume for the sulfuric acid. So that's 1.875 times 10 to the minus 4. The KOH moles is going to be double that. So that's 3.75 times 10 to the minus 4. So the volume required to deliver those moles is going to be volume is moles divided by concentration. So just beware that your answer is going to come out in dm cubed. Now sometimes my students leave it in dm cubed and forget to multiply by 1000 to get it into centimeters cubed. So titration questions, nothing to fear. In fact, I love them, me.